Quicksort algorithm. Quicksort algorithm is an algorithm that sorts an array. And whenever we hear quicksort, we always need to think about a pivot. That pivot is going to help us sort that array. Now, for the sake of our example, I'm always going to choose the pivot point as the last element of our array. So let's start. So we have this array to sort. And as I said, I'm going to choose the pivot point as the last element. And that is 5. So what we're going to do now is we're going to see which elements are smaller than 5 and which elements are greater than 5. So the elements that are smaller than 5, we can see are 2 is smaller than 5, 4 is smaller than 5, and 3 is smaller than 5. And the elements that are greater than 5 are 8, 6, and 7. So what happens is, now we're going to find the right place for 5 and put the elements that are smaller than 5 to the left, the elements that are greater than 5 to the right of it. So let's start. We have 2 here that are smaller, then we have 4, then we have 3, and then we're going to have 5 here. Because these ones are smaller than 5, and now we're going to put the ones that are greater. 6 is, but before we have 8, so 8 is greater than 5, 6 is greater than 5, and then there's 7, that is greater than 5. So what we did is, we found the correct spot for 5, because we know the ones that are left to it are smaller, and the ones that are right to it are greater than it. So that was called our partition step. And we're going to keep repeating this process. So we know the correct position for 5, and now we want to focus on this subarray. This one, 2, 4, and 3. And what we're going to do is, we're going to pick the pivot point in that array. And what we said was, we're always going to pick the rightmost element. So we're going to pick 3 as our pivot element. And we're going to see, so which elements are greater than 3 and which elements are smaller than 3. In this subarray, 2 is smaller than 3, and 4 is greater than 3. So what we're going to do is, we're going to put the element that is the smallest here, and then comes 3, and then comes the element that is greater than 3. So now we did another partition step, and we know that element 3 is at the right place. Now we're going to try this for the subarray we have here, which is 2. But we cannot sort this array because this array is already sorted. So what we're going to do is, we're just going to put 2 here as sorted, and now we're going to sort the array to the right of 3, which is 1 element and which is already sorted. So what we can see here is 2 is sorted at the right spot, 4 is sorted at the right spot, and we know 3 is sorted at the right spot. So we can replace these and show that this is the right sorting for this subarray. And we can go one step below and show that the left side of 5 is sorted. So it's 2, 3, and 4, and comes 5. Now we're gonna focus on the right side of the right side array of 5, which is 8, 6, and 7. Now what we have is, we're gonna choose the pivot point of this subarray, and as we said, we're always going to choose the pivot point as the last element of that subarray, which is 7. So what we're going to do is, we're going to see which elements are greater than 7 and which elements are smaller. So 8 is greater than 7 and 6 is smaller than 7. So we're going to start putting the elements in. 6 is the smallest one, and then comes 7, and then comes the element that is greater than 7, which is 8. So we can see that 7 is at the right spot, because all the elements to the left of it is smaller than that, and all the elements to the right of it are greater than that. And now we need to focus on the sub array to the left of 7, which is 6. But since 6 is a single element, and single element is always sorted, so we can just write 6 here and mark it as sorted. And now we need to focus on the subarray to the right of 7, which is 8. And we're going to see 8 is a single element, which is already sorted. So 8 is at the right spot. So now we're gonna check the order going back. So 6 has to be at this position. 7 we already knew was at the right position before from the previous step. So we're gonna write 6, 7, and 8. Now 6 is at the right position, 8 is at the right position. And now we can go back to this step and put these elements to the correct positions. 6 is going to be here, 7 is going to be here, and 8 is going to be here. And finally, this array we see here is the sorted array that we wanted to get. So what we did was we picked a pivot point, which was picking the rightmost element in each subarray, and then from there we used recursion to go down the steps and apply the same partition step to each subarray we have. And in the end, we found a sorted array which goes in an increasing order from 2, 3, 4, 5, 6, 7, and 8. Thank you.